Welcome to Lesson 7 Data Visualization in R. This is one of the important topic before we jump into statistics and machine learning about it. So R is one of the great tool where you can draw a lot of different kind of data visualization. And in data science, understanding that data is one of the most important, and these different kind of packages in R would actually help us to understand the data in much more better way. So we would be learning about two things. One is base package, which is inbuilt in R. Another one is ggplot2 package. Now there are different kind of packages apart from these two, like grid graphics and lattice graphics, but that is beyond the class. But you are suggested to go and check these packages and learn about it. But I'm sure if you learn the base package properly, then understanding the other advanced package would be cakewalk. So let's get into the packages. Now first is base graphics, which we are going to learn, which is easiest to learn and focus of this course. And grid graphics is also powerful set of modules for building other tools. Lattice package is also a very powerful general purpose system tool, and ggplot2 actually works on the grammar of graphics. So once we'll discuss about the ggplot2, you would understand. But right now let's discuss about the base package of R and how to create different kind of visualization. So before we actually get into different kind of plot, let's understand why do we need different kind of plot. Because whenever we try to do a lot of prediction kind of work, suppose I want to predict my sales based on weather, based on time, based on where my retail sales location is, based on product I'm selling in the retail outlet, all those things. Now interesting thing to look, all these independent variable by which I am trying to understand my dependent variable sales are not the same. Sometimes these independent variables are numerical in nature, sometimes it's categorical in nature, sometimes numerical but it has a less number of unique values. So depending on different kind of variable we have in independent and dependent variable, we need to learn different kind of visualization. Like if you talk about scatter plot, that is very good for plotting two numerical value. But if you talk about mosaic plot, that is mostly used where we have a categorical variable. So let's understand one by one and the syntax of this base package. So we are going to learn first scatter plot, line plot, bar, pie, histogram, density and box plot. These are basic visualization, and then we are going to learn about mosaic plot, heat map, 3D graph, correlation plot and word cloud. So these are one of the most important, but apart from these you might also find couple of interesting plot on your own. Now what is scatter plot? So scatter plot is something like you have X, you have Y and you have couple of numerical value. For like I can say for horsepower 150, the mileage is maybe 15. Similarly you can draw all those graphs. So this is most easiest one which we can do with plot function. So we have to use plot function and then we have to pass X and Y. So if you remember from our earlier example of empty car, where we had lot of different attributes like horsepower, mileage, cylinder, weight and all those things. So we are going to discuss about this scatter plot. And if you want to name this x-axis, y-axis, you want to name this title, you have different argument which we are going to learn. Like you can see xlab is for creating this x-axis, name of this x-axis, ylab is for this, main is for this, and if you want to select this range, how big it should be, you can do that by xlim and ylim. So let's get into the demo first then we can understand properly. So these are basics plot. So suppose let's create x variable, which is a numerical one, then y, and if you create a plot, then it would look like something. So if you remember, we have seen packages, these tab lot of times, we have seen help lot of times, but now this class would be mostly focusing on all those plots, and you can see this tab would be very much useful. Now, so what exactly we did? So x equal to 1, so y equal to 1 here, x equal to 2, y equal to 5 here. So you can create this kind of graph, that is nothing but a scatter plot. Now get into another example. Suppose I am creating a variable called dose, then drag1, drag b. So now if I want to plot dose by drag a, so I can understand the more the dose is increasing, the drag a, effect of drag a is also increasing. And similarly, if I can also see that if the dose increases, the drag b decreases. Apart from this, as you can see, this is pretty simple. See, only x and y you can pass and you can draw a scatter plot like that. But there are a lot of other arguments which you should know to create more beautiful visualization. Like you can see, apart from x and y, there is another argument which is type. So what is type? So suppose by default it was p. By default value type was p, where I am drawing the plot as this p equal to points. But what about you want to do it by a line? Then you have to pass type equal to L. Similarly, if you want to have both of them, point as well as line, then B. Similarly, if you want to do it, C is for the lines part alone B. Then O is for both over plotted. Then H is for like histogram. S is for step, and N is for no plotting. N is okay, so S is repeated. Let me remove this, and then N is for blank. So you might be thinking that why someone would actually create this blank, but this is one of the most important plot we would learn in a moment. But before we go into the next plot, let's understand with another example. So if you remember, so we used earlier mtcar data set from mass package. This was the data set where there was 32 different kind of car brand, and we had 11 variable for each of those brands. So mileage, cylinder, displacement. Just to remember, I have given you the link where you can actually find the description of this. So I have already copy pasted. So this is mileage, then cylinder number, then displacement, horsepower, real axle ratio, weight, Q-sec, then V-shaped or straight, then automatic or manual, then how many number of forward gear, and then number of carburetor. So these are the 11 attributes we had. And you can see the summary of mtcar as well by looking into the summary function. And now let's create a plot. Now if you remember, earlier we plotted x and y, but suppose we want to plot two different attribute of a same data frame, or maybe two different attribute of two different data frame. Both can be done. So suppose we want to create this plot, mtcar HP versus mileage. But now if I want to create horsepower versus gas mileage, so I change the name of the x-axis by this, which is x lab equal to horsepower, y lab equal to gas mileage. So exactly I can understand. Now what about I want to create a title? Then you have to give the argument called main, then the title would be created. So now apart from this, so we have learned two things. One is how to create a scatter plot x and y. Then we have also learned another argument called type, and then we also learned this x lab, y lab and main, how to create the title for x axis, y axis and the main title. Now what about these? You are not satisfied with the range. Suppose this is from 50 to 350, that's why it's looking good. But what about if it start from 50 to 1000? Then it would be very small. That's why lot of time we have to control the limit, control the range of x axis. So how do we do it? So we do it by x lim and y lim. So that is the controlling part. Now what I want here, I want 0 to maximum of horsepower. Then similarly here in y axis, 0 to maximum of mileage. So first let's create the maximum of horsepower and mileage. So how to do that? By using max function, I am passing empty car HP, that is my maximum horsepower and this is my maximum mileage, using the maximum function. And now I am passing in x lim, that I want from 0 to maximum of HP, and in y axis 0 to maximum of mileage. And then rest you already know, x lab, y lab and main, how to create. And I am saying type equal to p, which is nothing but for this plot. So this is how a scatter plot is done and been created.